Hi, I'm Elry with JTech, and today we're going to be discussing relays. Here we have your basic 5-prong relay, and the whole reason that we use relays in automotive is because the whole thing behind this is we're using a smaller current to control a bigger current. So using the smaller amperage to control the bigger amperage through a switch. And this here diminishes having to use big bulky switches that you couldn't probably even fit into an automobile, wouldn't fit with all the other components. So the way this works is this relay, it has a coil here that is basically a magnetic field. When there's power put to this coil, it creates a magnetic field that closes the switch and allows current to flow through that switch, and then cuts any component from a fuel pump or anything else on or off. Okay, like I said earlier, this is a 5-prong, and each prong or terminal is numbered. You have 30, which is usually your power side, 87, which is usually the device side, and 85 and 86. And you can have power through 85 and 86. When power is put on the 86 or 85, the magnetic field is created, and it closes the switch, which is on this side here, which is 30. And to test that, I have a digital volt ohm meter, and we should have resistance between certain terminals, and certain terminals won't have any resistance. Like if I use this and put it on terminal 86 and put my other on 85, I will have a resistance, and I'm showing on my meter here about 69 ohms, 68, 69 ohms, and that's fairly lower than most relays, and that is because this one has a resistor in it. If it didn't have a resistor in it, the more common reading in ohms would be around 78, closer to 80. And here we have one taken apart. You see this coil here is hooked to contacts 85 and 86, and when you put power to this, the magnetic field creates and controls the switch. It closes the switch or opens it, depending on if it's normally open or normally closed. And that you can control something with a bigger amperage flow. And that concludes the video.